This lecture, we are going to start with hydrocarbons. Now, this is the other part to complete the Chem 102 lecture series. Of course, we looked at the introductory aspects while when we resumed. I'm going to send those lectures for the introductory aspects. We are to continue with the hydrocarbons. Now, when we talk about hydrocarbons, they are not something that is new to any one of us. So let us have a discussion on what hydrocarbons are all about. Now, when we talk about hydrocarbons, there's just one thing that should come to our mind. That is, from the name, hydrocarbon, compounds that contain what? Hydrogen and what? And carbon. Are you getting it? All compounds that contain only carbon and hydrogen as the elements that are present in them are called hydrocarbons. Is that okay? Any compound at all that contain only hydrogen and carbons are known as what? Hydrocarbon. Are you getting it now? Now, hydrocarbons play key roles in our daily life. Most of the fuel we use, they are actually made from hydrocarbons. For instance, you must have heard of terms like LPG. LPG means what? Liquefied petroleum gas. Are you getting it? Then CNG. You know, recently, when the price of fuel skyrocketed, like when the price of fuel was increased due to the removal of fuel subsidy, so many persons started converting their vehicle from using a normal PMS, which is petroleum motor spirit, towards CNG. Are you getting it? Now, what is the meaning of this CNG? CNG means what? Compressed natural gas. All these are from hydrocarbon. Another one is LNG, which is what? Liquefied natural gas. Now, hydrocarbons are also used for the manufacture of polymers like polyethylene. When you hear of the word polyethylene bag, they are polymers of what? Ethene. Ethene is an hydrocarbon. This is ethene, CH2, double bond CH2. This is what? Ethene. It contains only carbon and what? Hydrogen. It is an alkene. And alkenes, they are what? Hydrocarbons. Polypropane, the same thing. And then polystyrene, all these, they are hydrocarbons made up of only carbon and hydrogens. And they are also used for as solvent for paint and starting material for the synthesis of dye and what? Drugs. Now, what are some dye that you know? Of phenolphthalein, those on their dye, methyl red, their dyes. Drugs. Now, for instance, your paracetamol, the starting material for the synthesis of paracetamol is benzene. And I remembered when they said the Dangote refinery can actually produce benzene. We said Nigeria is making waves in API manufacture, that is raw material, active pharmaceutical ingredient. Are you getting it? And benzene is one of the starting material for the synthesis of most drugs. Drugs like, let's say, paracetamol. The starting material is what? Is benzene. Are you getting it? And so many other drugs. Acetylsalicylic acid has benzene ring. Are you getting it? Then from other reactions, you can actually synthesize acetylsalicylic acid, which is aspirin, pain relief. Do you understand the concept now? So hydrocarbons, they have wide applications in our daily life, from our fuel, polymers, as paints and dyes, and starting materials for the synthesis of drugs and other materials. Is that okay? Now, basically, we say hydrocarbons are classified based on the type of double bond present. Now, saturated hydrocarbons. The only saturated hydrocarbon we have is, of course, alkane. Alkanes are single bonded saturated hydrocarbons. Are you getting it? Single bond. That means they have carbon, single bond, carbon. Then the unsaturated hydrocarbons are actually two. We have alkenes, and then we have alkynes. Now, the alkenes, they have carbon double bond carbon, and then the alkynes, they have carbon triple bond carbon. And then we have the aromatic hydrocarbon. Now, when we talk about the aromatic hydrocarbon, the gold standard for actually representing the aromatic hydrocarbon, when I mean the gold standard, I mean a good representative of the aromatic hydrocarbon most times is usually benzene. So when we talk about aromatic compound, benzene is what usually comes to our mind. Are you getting it? Benzene is an aromatic hydrocarbons. Now, what distinguishes this unsaturated from aromatic? Now, when we are talking about some of the properties of aromatic hydrocarbons, we said one, they must obey the Hooke's 4n+1 rule. That is one. And then another thing is that they must 4n+2 rule rather. And then another thing is that they must be conjugated and they must have odd number of pi bonds, right? And benzene satisfy those criteria that we listed earlier during the course of our lectures. All right, so that is the differences between aromatic hydrocarbons and the alkene, because they all also have carbon double bond carbon, but this one is conjugated. Now, when we say something is conjugated, it means it has alternate single and double bond. Alternate single and double bond. Now, when we say something is alternate, it means after a single bond, what you have next is what? A double bond. After a double bond, what you have next is what? A single bond, just like that, alternating, single bond, double bond, single bond. For any compound to be aromatic, it must have this alternate single and double bond. Is that understood? Now, having looked at that, so that makes the hydrocarbons to be classified into three: saturated hydrocarbons, unsaturated hydrocarbons, and then we have the aromatic hydrocarbons. All right? Basically, when you want to talk about the classification based on aromaticity, you can say they are classified as aliphatic and what? Aromatic, right? Now we are going to look at all that as time progresses. Now, let us look at alkanes alkane proper rather. Now the question is, what are alkanes? So if I should ask each and every one of us in this class what alkanes are, I believe we will be able to say one or two things based upon what we have learned in our secondary school. So the question now is, what are alkanes? What are alkanes? Give me your own definition. What do you think alkanes are? Right? Now, we said alkanes, they are saturated open chain hydrocarbons. Are you getting it? They are saturated open chain hydrocarbons. Now, we also have cycloalkanes. Take note. But the ones that we are going to look at in this lecture, they are the open chain alkanes. Are you getting it? So alkanes are saturated open chain hydrocarbon containing a carbon-carbon single bond. Are you getting it? The functional group, that is what is used to actually indicate the alkanes, are carbon-carbon single bond. And the first member of the alkane family, that is the homologous series, is methane. Methane is the first member of that homologous series. Now, these hydrocarbons are inert. That is, they do not react under normal conditions. Are you getting it? They do not react under what? Normal conditions. Hence, we call them paraffin. They lack affinity. Are you getting it? They do not react with acids. They do not react with bases. They do not react with other reagents. Hence, they were known as what? Paraffin. Means they lack affinity. What is paraffin? So when something lacks what? Affinity. You call it what? Paraffins. Is that okay? Exactly. So that is that for the alkanes. Now the alkanes, you may be asked, why are alkanes called paraffin? Because they do not easily react. And why is it that they do not easily react? It's because it's very, very difficult for you to break this carbon-sigma-carbon bond. Very difficult for you to break this bond. Are you getting it? It is a sigma bond. And it is very difficult for you to break sigma bonds. Unlike pi bonds that can easily be broken. And the general formulas for the alkanes is CnH2n+2, where n is the number of carbon. Now, this general formula, there are exceptions to this general formula. Now, what exception do we have? Cycloalkanes. This is an exam question. Cycloalkanes do not have the general formula. The general formula for cycloalkanes are CnH2n, which is still the same general formula as what? Alkenes. Is that okay? Cycloalkanes do not have general formula for what? Alkanes. They have their own general formula, which is the same formula as alkanes. So you may be asking the exam, alkanes and cycloalkanes. I mean, alkenes. All right? Alkenes and cycloalkanes have the same general formula, true or false? The correct answer is true. Are you getting it? Alkanes and cycloalkanes have the same general formula. What is the general formula? We said the general formula is what? CnH2n, right? Why that of the alkane is the CnH2n plus 2, where n is the number of carbon atom. All right? So if carbon atom is 1, it will be what? C1H. 2 times 1 is 2 plus 2 is how many? 4, which is of course CH4, methane. So if you put, let's say, carbon number 2 into this one, becomes C2, right? And then we have H. 2 times 2 is 4 plus 2 is how many? 6, which is what? Ethane. And then it continues like that. Is that okay? The first member of the alkanes homologous series is what? Methane. Thus, they have the general formula of CnH2n plus 2. And they are inert under normal condition. However, they can react under very vigorous conditions. Is that understood? Exactly. Now that you've understood that, let us see alkanes, some basic alkanes, and their physical property. Now, we are going to look at this later, but let me just look at it briefly. All right? Now, write the structural formula for butane, pentane, hexane, and arrange the isomers in order of increasing boiling point. Write the various structural isomers for butane, pentane, hexane, and arrange the isomers in order of increasing boiling point. Now, my dear students, there's a way to actually go about this. Now, where's the way to go about this? Now, let us take the first one, butane. This one is butane. Now, when we talk about butane, the formula for butane is CnH2n plus 2. This is general formula for the alkane, sorry. Now, for that of butane, it will be what? Butane has how many carbons? 4 carbons. So it's going to be C4H. 2 times 4, 8, plus 2 is how many? 10. C4H10. Are you getting it? This is butane. Now, one thing that you want to know is, for boiling point, straight chain compounds have higher boiling points than their branch chain isomer. Is that okay? Straight chain compounds have higher boiling points than their branch chain isomer. Take note of that. So if a compound is straight chain, they have higher boiling point than their branch chain isomer. However, one thing that you should also take note that the more the branching, the higher the boiling point. That is, compounds that have increased branching has lower boiling point rather. The more the branching, the lower the boiling point rather. The more the branching, the lower the boiling point. The more the branching, the lower the what? The boiling point. Is that okay? So let us look at butane. Now, butane can have isomer. For instance, if you want to write normally, butane is, let's write it out here. Butane is what? CH3. This is straight chain butane. CH2, CH2, CH3. Now, having written butane like this, you can also write it as CH3, CH3, CH, CH3. What compound is this? This compound is 2-methylpropane. All right, this 2-methylpropane. Now is there any other isomer that can actually come out from here? No. So it is expected that the boiling point of this normal butane will be higher than the boiling point of this 2-methyl propane. Are you getting it now? So in terms of boiling point, we can say that butane, that is N-butane. N-butane means normal butane, the straight chain butane, has a higher boiling point than what? 2-methyl propane. Are they isomers? Yes. We have done isomerism before. So the question now is, are they isomers? Yes. Are you getting it? But one has a higher boiling point than the other. Why? Because the straight chain isomer should always have a higher boiling point than the branching compound. Is that understood? Now let us look at the next one. The next one is pentane. Now pentane can have two isomers. So let's write it pentane. All right, so we can add this thing to this one here. So here becomes CH2. Here's what? CH3. This is pentane. Let us write the structural isomers for pentane. Now, if it becomes branched at what position? Let's say CH3, CH, this CH3, CH2, CH3. This becomes 2-methyl butane. Is that okay? 2-methyl butane. So we are going to write under here 2-methyl butane. All right. Now let's write for another one. You can have CH3, C, CH3, CH3, CH3. What compound is this? This is 2,2 dimethyl propane. Now, why do we call it dimethyl propane? 2,2. Now, we called it 2,2 because if you look at this compound very well, you agree with me that this is carbon number 1, this is carbon number 2, this is carbon number 3. At position number 2, there is a substituent methyl group. At position number 2 here, there's also a methyl group. So since there are two methyl groups, you call it dimethyl. So that is why we call it 2,2 dimethyl. The longest continuous chain is propane. This one too, if you number from this side, this 1, 2, 3, 4. 2-methyl butane. And then this one here is N-butane. N-pentane rather. Now, most persons also call when the substituent is only one substituent and it is attached at position number 2, we can also count this together and call it what? Isopentane. So instead of 2-methylpentane, you could also call this as what? Isopentane. Is that okay? Whenever the substituent is only one substituent, like CH3 substituent, and it is attached at position number 2, are you getting it? Then we can call this, just count the total number of carbon 5 and put iso before it. So it's either you call this 2-methylbutane or you can call it isopentane. This is N-pentane and this is 2,2-dimethylpropane. Now, between these three, which of them will have the higher boiling point? That is what we are here for. Now, you agree with me that based upon what we have learned so far, I told you that let me reduce this one. I told you that N-pentane will have the highest boiling point, which will be greater than, between these two, which of them is more branched? Between 2-methylbutane and 2,2-dimethylpropane. Of course, 2-methylbutane is less branched and 2,2-dimethylpropane is more branched. So this one will have the next highest boiling point because we said the higher the branching, the lower the boiling point. So the next one that will follow will be 2-methylbutane, or you can call it isopentane. And then greater than, the last one will be 2,2 dimethylpropane. Do you get your understanding now? Now for hexane, this will be your assignment. For hexane, tell me the possible isomers that we can actually form branched chain isomers. Are you getting it? Branched chain isomers that we can actually form from hexane and arrange them in order of increasing boiling point. Is that okay? Arrange it for me in order of what? Increasing boiling point. That is that for that question. Now, all right. There's a mistake somewhere here. Now let us talk about the nomenclature. Nomenclature has to do with naming of the alkane. So if you are given any alkane, how are you going to name it? Now, naming of compound is a very simple thing, especially when it comes to the alkanes. Now, you'll be given different compounds. For instance, you may be given a compound like this. And then you are expected to name this compound. All right. Now that you are given a compound like this, now how do you name a compound like this? First of all, we have to bring out the atoms that are present in this compound. You cannot just name it by just looking at it. Now in the exam, nobody will give you something like this. One thing that you should take note of, your exam is CBT. Nobody will draw structure like this for you. Now what will they give to you? They will convert this to the condensed form. I told you that whenever you have a structure like this, here is carbon, 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 here is carbon. Here, there are 3 hydrogens that we need to add to this carbon to make it 4. Here, we need to add 2 hydrogen. Here, 2 hydrogen. Here, 1. Here, 3. Here, 2. Here is what? 3. So if we want to bring this structure out based upon what we have learned before, this structure will be CH3. Are you getting it? Then followed by what? CH2. Then followed by what? CH2. Then here will be what? CH. Then here will be what? CH3 on top. Then continue to give us CH2. And here's what? CH3. Now, the first thing you need to do whenever you are giving anything like this is to identify the longest continuous chain. Is that okay? Identify the longest continuous chain. So my dear student, the question now becomes, which of them is the longest continuous chain? The longest continuous chain is usually that chain that is longest and it is joined to each other just continuously like that. What do I mean by that statement? The longest continuous chain must not necessarily be a straight chain. It can be a branch chain. Are you getting what I'm saying? But most times we usually just say the longest straight chain. No, the longest continuous chain can be branched. So it is that chain that is longest and it just continues, whether it is branched or curved or hexagonal or any shape. That is not your business, so long it is long and it is continuous. Now in this case, of course, the straight chain is the longest continuous chain. So if you want to count, here will be 1, 2, 3. Now having identified the longest continuous chain, the next thing you are now going to look at, my dear student, is which of them is the longest continuous chain? Of course, this chain that runs like this is our longest continuous chain. The next thing you're now going to look at, number from either extremes of the longest continuous chain. What do I mean? Number from either sides of the longest continuous chain, starting from the first carbon. You can either number from the right or from the left. Is that okay? Now the question now becomes, which direction are you going to number from? You number from the direction that we get to the substituent first. Is that okay? You number from the direction that we get to the what? To the substituent what? First. That's the direction you number from. So in this case, our direction will be 1, 2, 3, 4, 5, 6. Now, you can still decide to say, okay, you are stubborn and you want to number from this side. If you number from this side, here's 1, 2, 3, 4, 5, 6. If you look at the substituent, which of them actually have the lower number of the substituent? Of course, question number 3 has the lowest number. So you take this numbering as the correct numbering system. Is that okay? Now that you've taken that number as the correct numbering system, what do you think is the name of this compound? It's a very simple thing. At position number 3, you have a substituent there. What substituent is that? Is a methyl substituent. So first of all, you write the position. So this is 3. And then you have methyl. And then hexane. The longest continuous chain has 6 carbons. And from homologous series, I've taught you before, 6 carbons is for what? Hexane. So the name of this compound is 3-methyl hexane. Is that okay? It's a very simple something that you have been given here. Now, my dear students, how about if you have, let's say, something like this? I will enhance to number. Now, how are you going to start your numbering? Like I said, the longest continuous chain, first of all, we have to know the longest continuous chain. Now, the longest continuous chain is that chain that is longest and it is continuous. Of course, just looking at it, you agree with me that this from here like this, the chain that ran from here, is there a way? Okay, yes, I can actually use this. The chain that ran from here, through here, like this, like this, like this, like this, like this, to here, is our longest continuous chain in this case. Are you getting this? The chain that is longest and continuous. Do you understand? So longest continuous chain, you can actually take a branch. This is not a substituent.